So, as now we have completed the course outcome and syllabus. So, now let us start with the first unit of basic signal system subject. In this the topic is introduction to continuous time signal and system, in which we will study about what are the different type of signals and what are different types of system, what are the properties of system, what are different operation we can perform on the signals, and how we can develop a new signals using the combination of the all other signals. Okay. So, let us see. Okay. So, first of all what we are saying is what do you mean by signal? So, as we have discussed, signals are variable that carry information, that means anything that carry information can be called as a signal, and we can signals, and how we can describe it. Suppose if I am telling us if I am saying our input is a sinusoidal signals. So, that mean a signal is basically of this form. Okay. So, it can be, so what is it is Instagram is saying that it is described as the function of one or more independent variables. So, what is this? What we have studied? If we write our signal as Vm sin omega t. So, what is the variables? So, here we have, so this is basically a independent variable, and this is basically dependent variable. So, here the variable is what? Time. So, basically we can also say this is the basically mathematical representation of a signal. This is basically a mathematical representation of a signal. This is basically so. Third is basically it is a physical quantity vary with some independent or dependent variable. So, same thing which I have said. Now, third is signal can be one dimensional or it can be multidimensional. Now, next, as we have seen that this was the one order, it can also be a form like x t is equal to V m 1 sin omega 1 t plus V m 2 sin omega 2 t. So, it can be an addition of one or more signal also. So, function can have, so here we have two variables, we have one variable omega 1, one variable omega 2. Again, what are the basic example? Voltage, current, or any heartbeat, or blood pressure, temperature, vibration, or anything. Even if you are pointing something, or if you have giving a noise, noise is also a form of signal. But when we say signal, so what do we mean? That it should carry some useful information. If we say what is difference between signal and a noise, so we can say signal is basically carrying a useful information, whereas a noise might not be carrying any useful information, that is of no use. A noise is a signal basically does not carry any informative or valuable information. So, what are the basic classification of signals? So, signals are basically classified into 5 different domain. The first is continuous time and discrete time signal, second is periodic and non-periodic, third is causal, non-causal, deterministic and random signal, and fifth is even and odd signal. So, we will be discussing one by one detail about this different signals. So, first of all, what is continuous time and discrete time signal? So, as we know, any signal that takes a real value for every instant of time, that will be called as a real signal. For example, if we look up if you look at this graph, so this graph or this signal is having a value for each and every time domain, even from -4 to 4. So, when we talk of signal, it can be for signal also, for signal we can have a negative time as well. For signal we can have negative time as well. So, this signal was, suppose if I currently say that if I am standing at t is equal to 0, that means the signal was available from -4 to 4, that means 4 second before the current time and 4 second after that current time. So, it will be having a continuous value for each and every time, whereas when we talk about discrete signal, so discrete signal will not be having value for throughout the interval, it will be having for a particular fixed domain. For example, see, it is having a value on -4, then on -3, -2, -1, 0, but it is having no value for suppose -3.5. So, the signal is having no value for -3.5. Okay. Again here also for 2.5 also we are not having any value for the signal. So, when a signal having value throughout the time, that is this continuous, and it is when it is having a signal only for means a particular time, that is called as discrete. Now, the second is periodic and non-periodic. It is basically how can we represent, suppose if we want to represent that a signal is periodic. So, we can easily write as x t is equal to x t plus n t. That means for after a fixed duration of time or after some duration of time, it is again going to repeat the same value. For example, suppose if we draw a sinusoidal signal, this is the basic fundamental cycle, this is the basic fundamental cycle. If it is having time period t, that means if we keep t is equal to 0, then we will have what we will have? We will have this signal. Again if we keep t is equal to 1, then what we will have? We will get this part. Again if we keep t is equal to 3, then again we will get the next cycle. So, if you keep on increasing with the value n here, that particular time period will be getting added into a signal, and you will be getting what? Same signal. Means a signal is keep on repeating after a fixed interval of time, that the fixed interval is called as time period of that signal. So, periodic signal have the property that x t is equal to t plus t is equal to x t for all t, for any time. If you even change the time, still it will have the same value. The smallest value of t that satisfy the definition is called as period. What I have defined as period? See, if you keep n is equal to 1, means smallest time interval, smallest the first duration, the first cycle, when that first cycle has started, when that first cycle has completed its duration, that time duration is called as the period of that signal, or you can call it as fundamental time period. Basically, it can also called as fundamental time period. Again, so if you can see through the graph, so this is basically a signal, and if the signal is, and this is an example of periodic signal, because it is, and what is the time period? See, the signal is basically what? This is the signal which is getting repeated. So, this is a difference between periodic and aperiodic signal, or periodic or non-periodic. Again, now what is causal and non-causal? If a signal is having information only after t is equal to 0, if a signal is carrying information, or if a signal is only available for t greater than 0, then that is called as causal signal. And if a signal is not available or is only available for negative, that is t less than 0, then that is called as non-causal signal. So, see the example. So, this is the example of what? Causal. Why? Because the causal signal is 0 for t less than 0. See, t less than 0 there is no signal, but the signal is started at t is equal to 0 and it will exist for t greater than 0. But in the case of non-causal signal, what we have? We have a signal only in the negative time duration, not in the positive time duration. Similarly, we also have one anti-causal, causal, non-causal, anti-causal. So, we will see it later what is anti-causal. Again we have now similarly this signal we can keep the another name to this, that is we can call this signal as right handed signal, or we can call this signal as a left handed signal. So, right handed and left handed are the basically other name for the type of causal non-causal. For example, see, a right sided signal is 0 for t less than t. See, this is a signal which is starting from t and going in the right domain, going in the right direction. Similarly, this is a signal which is having its extinctions in negative half. It is starting at, see what is the difference between causal and non-causal and right and left handed. In causal signal, the signal must not be present in the negative time duration or negative period, but in right hand signal or left hand signal, there is some signal in the negative domain or there is some signal in the positive domain, but it should exist or it should continue in the particular direction. For example, if a signal is right handed, means it may start from here. If we represent this signal for causal, what we can do? We will shift this signal here. and then we can call the signal as causal. Similarly, if we want to call the signal as non causal, what we will do? We will shift this point to 0 and that will be again become non causal. So, this is the basic difference between causal and non causal. We can also call this signal as right hand signal, but we cannot call right hand signal as a causal. Okay. So, at final we can write all causal signals are right handed, but all right hand signal are not causal. Okay. Again the next classification is deterministic and random signal. So, any signal that is, if we know, for example, if we talk about any signal, suppose a square signal or triangular signal. So, suppose if we know, so this signal is particular name, that is why we call it as deterministic. We know the nature, it will where it will go, where it will repeat, but when this, if a signal is, suppose for example, this is a signal which is deterministic in nature because it is following some pattern. But if a signal which, if there is signal which does not follow any pattern, suppose if I talk signal like this, it is not following any pattern, so we cannot name this signal. So, basically if we are not able to name any signal, we can call it as random signal. But if we are having a signal, we know the property, we know what will be the further coming output. For example, suppose if the pulse rate have some random pattern, but we know that it cannot, pulse rate will cannot go like this. It will be having some random pattern, but random pattern must be in an organized manner. But in a random signal, the signal we do not know what, if we know, we do not know what is at t is equal to 2, or if we know the value f of any signal at t is equal to 2, if you do not have any idea what it can be at t is equal to 4, then we can say the signal is of non deterministic or random signal. But if we know the value at t is equal to 2 and we easily determine the value at t is equal to 4, then we can say that signal is having some property, or it is, can call it as a deterministic signal. So, behavior of this signal is predictable with respect to time. There is, so these are the point, behavior of the signal is predictable with respect to time, there is no uncertainty with respect to its value, this signal cannot be expressed in mathematical form. So, deterministic can be expressed in a mathematical form, whereas a random signal cannot be expressed in a mathematical form. Okay. So, basically what I have told, a noise is a best example for a random or non-deterministic signal. Basically a random signal is comes under the category of non-deterministic signal. We cannot represent a noise using any mathematical formula. Now, what is even and odd signal? So, I have said if a signal is following the property of x t is equal to x in minus t, then we call the signal as even signal. So, what we can see, the value of signal is same for t and minus t, that means the signal must be symmetric about y axis, then only it is possible that it can satisfy this statement. So, we can, if we are required to find whether signal is even or odd, we will generally, we will see by seeing the graph, we can say if a particular graph or particular signal is symmetric about the y axis, then that is a even signal, whereas if a signal follow the property of x t is equal to minus x minus t, then that is called as odd signal. That means this signal is, how we can represent that signal? This signal must be symmetric about origin. This signal must be symmetric about the origin, then only we can say that this function can be satisfied. So, these are various examples. See, this is the signal. So, this signal, if we add those signal, we can get this signal. So, this signal is symmetric about origin. Similarly, symmetric about y axis, and if a signal is symmetric about origin, that comes under the property of odd signal. So, when we further study, we can say that any signal is a sum of unique odd and even signal. Any signal can be represented in the form of summation of even plus odd signal. So, same will be for discrete system. This is for what continuous signal, and this is for discrete signal. Similarly, for odd signal, this is for odds for continuous, and this is for discrete. Again, what we have, any signal that can be represented in what we have discussed, any signal can be represented in the form of sum of even plus odd signal. Okay. So, what is bounded and unbounded signal? Suppose if a signal is going like this, means it is not decaying or it is continuously increasing, that signals come under the category of unbounded signal. And if a signal it is of decaying nature, if it is like this, or then this we can call this signal as a what, a bounded signal. So, every system is bounded, but meaningful signal is always bounded. So, this is every system is bounded, and but meaningful signal is always bounded. If a signal is not bounded, so we will not be able to get a very useful response from that signal. Also, see, when we defined stability of a system, if we define, then we can say for stability it must have BIBO, means bounded input and bounded output. For stability, see, bounded output, here it is saying that it must have bounded output. Any system that is giving bounded output, we can call that system input, but it should also, the input must also be bounded. You can never have a unbounded input giving bounded output, it can never happen. You must have to give a bounded input in required to get the bounded output. So, only if this bounded input is there and we are getting bounded output, then only we can say that the system is having a stability or system is following some stability. Now, what is power energy signal? So, again, if we define power energy signal, okay. So, see, power signal, first of all we will discuss about energy signal. So, energy signal. So, how we represent energy signal in mathematical form? So, also you know that how will what relation between energy and power, what relation? So, we will have energy is equal to power upon time, or we can say power, sorry, so power is equal to rate of doing work. So, P is equal to E upon T. So, we already have E. So, if you want to find P, what we will do, we will divide it by time period minus T by 2 x T dt. So, this is the representation of energy signal, power signal. This is the basic difference. This is infinite duration, this is having finite duration. See, this is the infinite duration is for energy signal, and it is for infinite duration we have power signal. Then again, normalized power is finite and non-zero, normalized energy is, average energy is finite, mathematically tractable, physically realizable. We can realize energy signal, but we cannot realize power signal. Now, see, there is one thing we must know, that how we can identify whether a signal is power signal or energy signal or neither of that. So, basically there is three category. It can have power signal, it can be energy signal, or it is neither energy nor power. Basically there is basically three category. So, remember there is one rule, if any signal is unbounded in nature, any signal is unbounded in nature, or it is having a value infinite, if we having a signal is having value of infinite at any time duration, then we can say that signal is neither energy nor power signal. Okay. So, we can easily identify any NP. Now, if we are required to identify energy signal, so how we can identify energy signal? See, any signal that is bounded, any signal that is bounded, that will be energy signal, or any signal that is having decaying component. For example, if a signal is like this, although it is for infinite duration, although it is for infinite duration, but it is what? It is bounded, it is getting decaying nature. So, this type of signal fall under the category of energy signal, and if any signal it is not having this property, which is not having this property, we can say then that signal is a category of power signal. So, if we take example, see, if we say suppose this is one pulse train, and if I ask you what is the nature of this signal, under which category this, under which classification the signal falls. So, you can easily say that if we find the integration of the system, if we find integration, so what we will get? So, here we will get infinite, because the signal is going from minus infinity to plus infinity. So, the energy E is infinite. Okay. So, this is what this is also. Now, let us identify from the what we have learned. So, let us check what is this come on the category of any NPC. It is having any point where the value is infinite? No, this signal is not having any point, or there is no time throughout the signal where the signal is showing infinite. So, this is not a any NP signal. Again, now whether that signal is bounded, it is having only, it is not existing from infinite to infinite, is it bounded? No, it is from minus infinite to, so it is not also energy signal. What is another type? Is it decaying in nature? No, this is, there is no decaying nature. The amplitude is constant and is from minus infinity to plus infinity. That means this signal is neither energy nor power. Yes, it is, this will come under the property of power signal. Okay, this will be category of power signal. Other example, if we take, this is e to power minus t, this will be also what, this will be having decaying nature. That means this will come under the category of energy signal. Okay. Now, okay. So, now we must know how we will process a signal, or what are different operation which we perform on a signal. So, we already know time inverse. Suppose time, the first is time reversal. That means suppose if this is a signal which is we call is as xt. So, what is time reversal? Time reversal is xt can be reversed minus t. That means it will be like this. Whatever be value at 0 to t, it will become t and 0. The signal will what will get its mirror image in the y axis, that is called as time reversal. The mirror image of the signal on y axis is basically time reversal. Then other thing is time shifting. So, what is time shifting? See, suppose there is one signal like this, minus 2 to 2, minus 2 to 2. If I ask you, so this can be written as xt, suppose this is the signal xt. Now, if I ask you to write xt plus 2, xt plus 2. So, what is this? How can we do this? Xt plus 2 will be like minus 4 minus, sorry, it will be like minus, okay, what was the signal? Signal was here minus 2 to minus 4. So, it will be minus 4 to minus 2 origin. So, what is this? The signal, this was x t, this is x t plus 2. So, this has, so what we will call, this is called as time shifting. What we have shifted? The time. So, what we will say? This is also called as time advancement. So, what has the whatever value of signal was at x t is equal to 0, now that value will come at what time? T is equal to, whatever the value was at t is equal to 2, that value has shifted to t is equal to 0. So, this is what called as time shifting. Then we have amplitude scaling. Suppose this is a signal x t and it was having magnitude 2, and if I want to scale the magnitude, if I want to write y t is equal to 2 x t, that means amplitude must be multiplied by 2. So, how we will write y t? So, y t can be written as minus 2, there will be no change in the time, only the amplitude which was originally 2 will become what? 4. Okay. So, this is basically time shifting, sorry, amplitude scaling. Then we have addition, this is multiplication, again time. What is now, what is time scaling? The time scaling is, suppose the signal is existing from time minus 2 to 2, this is basically x t, and I want to write x 2 t. So, what will happen? How will represent x 2 t? X 2 t will be what? Minus 1 to 1. How? Because earlier, suppose if I keep here, if you want to check whether we have drawn the same the right graph or right signal, just check, put t is equal to 2, t is equal to 1. So, here x is equal to 1. So, what is the value of x equal to 1? At x equal to 1, it is this value. Okay. Now, if you want to get same input or same signal in this x 2 t, so what you will have to put? You will have to put t is equal to t by 2 or t is equal to 1 by 2. That means, time will be half. Earlier it was duration of 4, now it will become of 2. Okay. So, this was the basis operation on the signal. Thank you.